Hello, so in this video I just wanted to talk through some of the motivation behind confidence intervals. So this is kind of the first video that we're going to do, and then we'll kind of build on this, but I just really want you to have the idea of what a confidence interval is in your head. So what I have here, I'm going to use a sort of a motivational example to start off with. What I have here are some song lyrics, okay? They are Crazy in Love by Beyonce, and I just want to pose the question: what if I wanted to know what the average word length is? So by average, let's just say the mean, okay, rather than mode or median. What if I just wanted to work out what the mean word length is of the entire song? Now, clearly, one way to do it is to go through every single word, count the number of letters, and then basically just have like a list of the number of letters in each word, and then take the mean of that list, that set, okay? And that would be kind of the entire population, and it would be a correct value for the mean. But what if I didn't have time to do that? Like, I can't be bothered to go through every single word, count the number of letters, and then at the end add them all together and divide by the number of letters which they've got. It's going to take far too much time. So one thing that I can do is take something called a sample, okay? Now a sample is just simply, if I just take a selection of words at random and take the mean of that, then that should give me some information about what's happening at the population level. And in fact, we used this example when we were doing the central limit theorem, okay? And the idea is that obviously as you take more and more samples, you get a better picture of what's happening at the population level. So let's just pick sort of, 5 words at random then. So let's pick no. So no. Let's pick pride. Let's pick some words over here. Let's go crazy. Let's pick, a word up here. Let's go insane. And one more just at random. Let's just pick this one. So with, okay? So here are my 5 words, okay? So I've just taken a sample, and in that sample I've got 5 words. And then all I'm going to do is take the mean of the average word length of this particular sample here. So for example, I know that there are 2 letters in the word no, there are 5 letters in the word pride, 5 letters in the word crazy, 6 letters in the word insane, and 4 letters in the word with. Okay, so I'm just going to take the mean of this sample. So I need to add them all together. So I should get 22. Okay, then I'm going to do 22 divided by 5, which is going to be, what is it going to be, 4.4? Okay, so the average of this sample here is going to be 4.4. Okay, so the average of this sample here is going to be 4.4. Now, as we've seen with the central limit theorem, we know that if we take more and more things in this sample, it should be the case that we get a better picture of what's happening at the population, okay? So if you like, this is one sample, okay? Now this is a really key part, okay, really key point. I've got 5 words here. It does not mean that my sample size is 5, okay? Because actually in this case, I'm looking at the number of samples of 5 words. So this here collectively would be one sample, because clearly I'm taking the mean, and if I just took one word, I can't take the mean of one word, okay? I need to sort of select 5 words, take the mean of that, and then that is my sample mean, okay? So in this case, I have a sample mean, of 4.4, okay? Now I actually did this earlier, okay, and I actually took a few other sample means as well. So let's take, say, x bar 1, let's take x bar 2, I got 3.8, then x bar 3, I got, I think it was 5.6, okay? So I have sort of 3 samples here, and in each of those samples I've taken 5 words and just taken the mean of the number of letters of those 5 words in each sample. So actually in this case, my sample size would be 3. Because I've taken 3 samples, each with 5 words in. Okay, so hopefully that makes sense. Now here's the thing. We've seen with the central limit theorem that as I increase the number of samples, so as n approaches infinity, we know that the mean of these samples, so if I take the mean now of these 3 samples, so 4.4 plus 3.8 plus 5.6, so if I quickly do that on my calculator, a very sophisticated calculator. Okay, so if I do 4.4 plus 3.8 plus 5.6, add them all together and divide that number by 3, 4.6 is my sample mean. Okay, so my sample mean here is going to be 4.6. So the mean of all of these 3 samples put together comes out as 4.6. Now it should be the case that as we increase the number of samples, the mean of the number of samples that I take should approach the true population mean. We've seen this with the central limit theorem, okay? But it should also be the case that sigma, so the standard deviation, should approach 0. In other words, the spread of the distribution should become smaller. So if I just take a few different curves, let's say this is the curve for n equals 1. Okay, this is the expected curve for n equals 1. Then if I take more and more curves, for example, let's take n equals 10. Okay, so that would be n equals 10. Then if I take another curve, it will become even more like that. Okay, so let's say that's n equals 100. So as I take more and more samples, you can see that the spread of the distribution becomes smaller and the distribution becomes more and more centered around the true population mean. This is what the central limit theorem tells us. But okay, what if I just wanted to work with this mean here? So this mean of 4.6. What if I wanted to say, well, okay, it's unlikely that the true population mean is going to be exactly 4.6, okay? But I know that it's going to be somewhere close to 4.6. And obviously it's going to be closer the more samples we use, okay? So what I want to do is I want to introduce this idea of an interval. So I want to construct an interval such that I can say with some level of confidence that the true population mean is going to lie within this interval. And it's based on the existing data which we have. So it's based on the sample mean, and it's also based on the number of samples that we've taken. Okay, so let's have a look and see how we can do this. So effectively, I want to construct an interval that looks like this. So let's suppose I just have a number line. My 4.6, I'll just put that as a little dot here, so that's my 4.6. I want to say that my true population mean is going to lie within some range. Okay, so let's say the range is going to be from here to here. Okay, now let's just argue that that's just some parameter m, okay, which means that this point here, because of course this is just x bar, this point here is going to be x bar plus m, and this point here is going to be x bar minus m. Now the question is, what is that m? What is that kind of change which I have to consider? So I want to basically say within some level of confidence that the true population mean is going to lie somewhere in there. Okay? So, well look, here's what we need to know. We know that it's going to be dependent on the sample mean, so this interval is going to be dependent on the sample mean, but m is specifically going to depend on two things. It's going to depend on the sample size. So m will depend on the sample size, but it will also depend on the confidence level. Okay, now the confidence level is just simply, well, how confident do you want to be that the true population mean is going to lie somewhere in this interval? Okay, so it's going to rely on sample size, and it's going to rely on the confidence level. So it needs to rely on these two things. Okay, as you change the sample size, fairly obviously, so as n increases, so as n gets bigger, fairly obviously, the margin is going to get smaller. Okay, because you're going to be more and more capable of narrowing down where that true population mean is going to lie. Whereas if you only select sort of one sample, that sort of margin of error is going to be quite wide because you don't really know much information. But obviously, if you go ahead and select 1,000 samples, that sort of confidence interval is going to be much smaller because you're going to be more confident about where that population mean is going to lie. Now, it should also be the case that if you define some confidence level, and we'll talk about what the confidence level means in just a second, but if you say, well, okay, I want to be more confident, okay? So I want the confidence level to be really high. Obviously, as the confidence level is high, then the margin of error is also going to be quite high as well. Okay, so the confidence interval is also going to be quite wide as well. Because obviously if you make the confidence interval really wide, then you can be more confident that the true population mean is going to lie somewhere in that interval. Whereas if you have a low level of confidence, it means that margin of error is really small because it's unlikely, or it's much less likely that the true population mean is going to lie in that margin of error. Okay, so hopefully that kind of makes sense. This is the kind of core principles of what a confidence interval actually is.